All right, let's dive into the world of GPUs in Google Cloud. We're talking about making your virtual machines, your VMs, seriously powerful with these graphical processing units. And you've given us some great Google Cloud docs on this.
Yeah, it's a game changer to have access to that kind of power without needing a massive server farm, right?
Absolutely. And then the first thing that jumped out at me was that Google Cloud offers two main types of VMs when it comes to GPUs.
Okay.
N1 machines, which they describe as super flexible,
Yeah,
and then these accelerator optimized VMs, which sound seriously powerful.
it's like comparing you're like a Swiss Army knife
Okay.
to a high-powered laser cutter.
I like that.
Both useful,
Yeah.
but for different things.
Right. So the N1 machines are like that trusty Swiss Army knife, able to adapt to what you need. You can pick from different NVIDIA GPUs, T4s, P4s, even the heavy-duty V100s.
And the thing is, you're not locked into a specific setup, so you can customize that N1 machine with just the right amount of GPU power depending on what you need.
Right, so it's all about having that flexibility to scale up or down as needed.
Exactly.
Now, the documentation did mention that most N1 machines can handle these GPUs, but not the shared core ones. What's the deal with shared core?
Um, think of it like sharing a pizza with a friend.
Okay.
Shared core means your VM shares the GPU with others, which can be fine for some tasks. But if you need that GPU's full attention, you'll want a dedicated one.
So if your project is like a casual pizza night with friends, shared core might be fine. But if you're hosting a huge party and need all the pizza to yourself, you go dedicated.
Like that. That's a good way to put it. Okay, now on the other side of the spectrum, we have those accelerator-optimized VMs. This is where Google Cloud's packing some serious heat.
The laser cutters in our analogy?
Yes, we're talking NVIDIA's A100 and H100 GPUs. These are purpose-built for the most demanding tasks. AI models, deep learning, massive data crunching, the kind of stuff that would bring a regular CPU to its knees.
Okay, so if N1 machines are about flexibility, the accelerator optimized VMs are all about raw power.
Absolutely.
And I noticed these come in different varieties too, A3, A2, and G2 machines. What's the difference?
So it's all about which specific high-performance GPU they're packing and
Ah.
how that translates to the kind of performance they can deliver.
All right, let's break those down one by one, starting with the A3s. The docs mentioned those are the newest ones, right? Equipped with those powerful H100 GPUs.
Yeah, you got it. The H100 is the latest and greatest from NVIDIA, offering a huge leap in performance compared to older models. And Google Cloud offers them in two flavors, the A3 High and the A3 Mega.
Those names seem pretty self-explanatory.
Like,
More power as you move up.
you're catching on. Think of the A3 High as your high-end sports car.
Hmm.
It's got plenty of power for demanding tasks, especially if you need to train large, complex AI models. But then there's the A3 Mega,
That's like the supercar of the A3 family.
more like a rocket ship disguised as a VM. If the A3 High is a sports car, the A3 Mega is a whole fleet of them working in perfect unison. It's for those truly massive workloads, the kind where you're dealing with datasets so large they'd make your head spin.
I'm getting a sense of the scale here. So A3s are the newest and most powerful, but what about the A2 machines? I remember seeing those mentioned alongside the A100 GPUs.
Right, don't underestimate the A2 machines. They're still incredibly capable for a wide range of AI and high-performance computing tasks, just not quite as bleeding edge as the A3s. Google Cloud offers these in three variations, the A2 Standard, the A2 Ultra, and the G2.
We've already talked about the power of those A100 GPUs. What's the difference between the A2 Standard and the A2 Ultra? Is it just the number of GPUs, or is there more to it?
It mainly comes down to the type of A100 GPU they're packing. The A2 Standard comes equipped with A100 40GB GPUs, while the A2 Ultra boasts the more powerful A100 80GB GPUs. It's like the difference between having a spacious work desk and having an entire workshop. More memory means you can handle larger, more complex tasks without breaking a sweat.
So if you're working on a large-scale project, that extra memory capacity in the A2 Ultra could be a lifesaver. And what about the G2 machines? What makes them unique?
The G2 machines are interesting because they offer a different flavor of GPU altogether, the NVIDIA L4. While the A-series focuses on computing power, these GPUs are purpose-built for graphics-intensive tasks.
So we're talking high-end video editing, 3D rendering, maybe even game streaming, stuff where visual fidelity is critical.
Exactly. If your work is visually focused and you need serious graphical horsepower, the G2 machines with those L4 GPUs are the way to go.
Okay, this is a lot to process. We've gone from flexible N1 machines to the raw power of the accelerator-optimized VMs A3s for the most demanding tasks, A2s for a balance of power and affordability, and G2s for when stunning visuals are key.
And we've only just begun to scratch the surface. Google Cloud has a few more tricks up its sleeve when it comes to maximizing the power of these GPUs.
Okay, you've piqued my curiosity. What else is there?
Have you ever wished you could split one of these super powerful GPUs into smaller, more manageable chunks, especially when you've got multiple tasks running?
I mean, yeah, especially after seeing just how powerful these GPUs are, it almost seems like overkill to just have one task running on them at a time.
You're right, and that's where this next topic comes in. It's Google Cloud's answer to that very problem.
All right, then let's unpack that. What are we talking about here?
It's called multi-instance GPUs, and it's pretty cool. Imagine slicing up one of those powerful A100 GPUs like we were talking about into smaller, independent units.
Okay.
Each slice gets its own dedicated resources and can handle a completely separate workload.
So instead of one giant GPU laser cutter, I've got a team of smaller but still powerful laser engravers, each working on a different part of the project.
That's a great way to think about it. It's like having multiple mini GPUs within one physical unit, each with its own dedicated memory, processing power, even its own separate queue.
Okay, so I can see how that would be way more efficient than just having one giant GPU sitting there potentially half idle.
Exactly, and it's not just about cramming in as many tasks as possible. This also gives you incredibly fine-grained control over how those resources are allocated. You can prioritize certain tasks, give them more GPU power, or ensure that critical workloads always have the resources they need.
It's like having different levels of VIP access within your VM. Some tasks get the red carpet treatment with dedicated GPU resources, while others share the space but still get the job done.
Exactly. It's about making sure every task gets what it needs, when it needs it, without any one task hogging all the resources.
Right.
But let's step back for a second. We've been throwing a lot of GPU models and VM types at you.
Right.
Choosing the right combination is essential.
It's easy to get caught up in the excitement of all this power, but each choice comes with its own considerations. What are some of the key things I should be thinking about when I'm making these decisions?
Well, first of all, what problem are you trying to solve?
Right.
If you're working with massive data sets and need raw computational power for AI training, those A3 VMs are your go-to. But for something like 3D rendering or high-end video editing, where visual rendering is key, the G2 machines with those NVIDIA L4 GPUs might be a better fit.
So it's about matching the right tool to the job, just like in the physical world.
Exactly.
Yeah.
And it's about finding that sweet spot between performance and cost effectiveness. That's another area where those multi-instance GPUs can really shine. They allow you to maximize your spending by squeezing every ounce of value out of those powerful GPUs.
Right, because if I can divide up a powerful GPU and have multiple tasks running on it concurrently, that's going to be more cost efficient than having separate VMs for each task.
Precisely. You're thinking like a cloud cost optimizer. But keep in mind, it's not just about the hardware when you're working with GPUs. Software plays a crucial role too.
Okay, so we're talking about things like drivers and libraries, right?
Exactly. Just like with the graphics card in your computer, you need the right drivers for those Google Cloud GPUs to function correctly. The good news is, Google Cloud makes this relatively painless.
Oh, good, because the last thing I want to do is wrestle with driver installations when I'm trying to set up these powerful VMs. What do I need to know about managing those?
For most common machine learning tasks, installing the standard GPU drivers provided by Google Cloud will do the trick.
Okay.
They've done a good job of streamlining that process.
That's a relief. But I did see something in the documentation about deep learning VM images. Are those just pre-installed drivers, or is there more to it?
Those are a fantastic time saver, especially if you're diving into the world of AI and deep learning. Imagine having a pre-built artist studio at your disposal, complete with all the tools and materials you need, instead of having to set up every single brushstroke yourself. That's what these deep learning VM images are like.
So they're pre-configured with popular machine learning frameworks, libraries, everything you need to just get started quickly.
Exactly. Instead of spending days or even weeks setting up your environment, you can spin up one of these deep learning VM images and dive right into building and training your AI models. And not only do they save you setup time, they're also optimized by Google Cloud to squeeze every bit of performance out of that hardware.
So you're getting a performance boost right out of the gate.
Yeah.
That's pretty incredible. Speaking of performance, you mentioned earlier that local SSDs, those super fast storage drives, are a good pairing with GPUs. How does that all fit together? So we've talked about local SSDs being like clearing the roadblocks for those GPU race cars. What's the connection there?
It's all about data transfer speeds. When you're dealing with these massive data sets that benefit from GPU acceleration, how fast you can move that data around can really become a bottleneck.
Mhm.
Imagine having a high-speed train but running it on outdated tracks. You're not going to get its full potential. Local SSDs are like upgrading to those high-speed rails, making sure that the data can flow in and out of the GPUs as fast as they can process it.
Okay, that makes sense. It's about removing those bottlenecks and letting the GPUs work at their peak. Now, thinking about all this power, especially with multi-GPU setups, doesn't that put a strain on the network too?
You're absolutely right to consider that. With great power comes the need for equally robust infrastructure, and Google Cloud has addressed that with networking options specifically designed for these demanding workloads.
So what should I be keeping in mind on the networking front when I'm setting up these GPU-powered VMs?
Bandwidth is key. Think of it like this. A bigger pipe allows more water to flow through it right.
Right.
Similarly, higher network bandwidth allows for faster data transfer between your VMs and those powerful GPUs. Google Cloud offers various network tiers, so you can choose the one that best suits your workload.
So if I'm working with those A3 megas and huge data sets, I'd want to make sure I have a network pipe that's up to the task.
Exactly.
You mentioned troubleshooting earlier. Even with the best tools, sometimes things don't go as planned, right? What are some common issues people run into with GPUs in the cloud, and is there anything I can do to troubleshoot those myself?
Driver conflicts are a big one. It's like trying to fit a square peg in a round hole. If those drivers aren't compatible with your GPU model, things just won't run smoothly. Always double check that you've got the latest stable drivers and that they're the right ones for your specific setup.
Right, so always make sure those drivers are speaking the same language as your hardware. Anything else I should be watching out for?
Resource availability.
Mm.
GPUs, especially the high-end ones, are in high demand. It's possible that the specific configuration you need might not be immediately available in your preferred region.
So before I get too far down the road planning my project, it's smart to check what's actually available.
Absolutely.
Okay, that makes sense.
And don't forget, Google Cloud provides a ton of documentation and support resources. If you hit a roadblock, you're not alone.
That is reassuring. Now, this deep dive has been incredibly helpful in understanding the technical side of things, but I think it's time we switch gears and talk about the why. What can you actually do with all this GPU power in Google Cloud?
The possibilities are incredibly vast. We're seeing them play out in real-world applications across a whole range of fields.
Okay, give me some examples. What's got you excited?
One area where GPUs are having a truly profound impact is healthcare. Imagine being able to accelerate drug discovery, potentially finding cures for diseases that have plagued humanity for centuries. That's the promise GPUs are unlocking.
Hold on, really? How does that even work?
It comes down to simulating molecular interactions. These simulations are incredibly complex and require an immense amount of computational power. Think of it like trying to map out every star in the galaxy. It's a massive undertaking.
Okay, so instead of researchers spending years in a lab painstakingly testing different compounds, they can run these simulations on powerful GPUs and get results much faster.
Precisely. And because these simulations can run so much faster, researchers can test millions, even billions, of potential drug compounds in a fraction of the time it would take using traditional methods. It's like going from a horse-drawn carriage to a spaceship. The pace of discovery is just incredible.
That's mind-blowing. But it's not just healthcare, right? What are some other fields where GPUs are making a difference?
Finance is another great example. Think about financial analysts. They use these incredibly complex models to try to predict market movements, assess risk, make investment decisions. Those models involve analyzing massive amounts of data, crunching numbers on a scale that would make your head spin.
Okay, so that sounds like a job for GPUs.
You got it. By offloading these computationally intensive tasks to powerful GPUs, financial institutions can gain a significant edge. We're talking about faster, more accurate predictions, potentially leading to better investments, a more stable financial system overall.
That's really interesting. It's amazing to think about how this technology can impact something as complex as the financial markets.
Absolutely. And of course, we can't talk about the power of GPUs without mentioning the field that's on everyone's mind these days. Artificial intelligence, specifically generative AI.
Right, all those incredible AI models that can create realistic images from text prompts, write poetry, even compose music. I knew GPUs had to be involved in that somehow.
They are absolutely essential. These generative AI models, like the ones behind those amazing image generators, learn by analyzing massive data sets of images, text, or music. It's a bit like showing a child thousands of pictures of cats and dogs until they can tell the difference, but on a much, much larger scale.
So the more powerful the GPU, the faster these AI models can learn and the more impressive the results.
Exactly. And because these models can access and process information so quickly with the help of GPUs, we're seeing breakthroughs in AI happening at an unprecedented pace. It's really an exciting time to be following this field.
This has been an incredible journey. We've gone from the nuts and bolts of what GPUs are and how they work with Google Cloud VMs, all the way to exploring how this technology is shaping the future of healthcare, finance, and artificial intelligence. It's truly mind-blowing.
It really speaks to the power of technology to solve real-world problems and unlock human potential. And to think, this is just the beginning.
I can't wait to see what the future holds. This deep dive has given me a lot to think about. Thanks for taking this journey with us, exploring the incredible world of GPUs and Google Cloud. Until next time, keep exploring, keep innovating, and as always, keep diving deep.